Okay, this is another points, lines, and planes practice in the grade book. This one I think will be called the PLP with sketches. It's our second points, lines, and planes practice. Okay. It's number one's asking us to name a line that is not contained in plane N. So contained entirely in plane N. So line in our we have three lines drawn in this figure. We have BC, but BC is entirely in this plane. We have CD, which is entirely in the plane, and then we have AE, with this line is going up through the plane. So here's our plane. Okay, we got points C, B, D, here. Okay. Here's our plane. Point A is up above the plane. Point E is below the plane. Okay. We use this diagram in our notes. All right. So point A is above. Point E is below. So we know that that line AE, is not in the plane. So AE. Okay. We could have named it AB. We could have named it BE. We could have named it EA or EB. Those would all have worked. But that's the line that's not contained in the plane. It intersects the plane at one point. Okay, name two different ways to name the plane that contains point B. So B is in plane N, so we can name plane N in two different ways. One way is to call it plane N. Right, we can use the symbol in the corner. The other way to name it is to use 3 points that are in the plane that aren't all on the same line. So the 3 points that are in the plane that are non-collinear are going to be B, C, and D. So we can call this plane B, C, D. We need 3 points that are non-collinear to define the plane. It could be plane CBD, BCB, CDB. Any of those combinations will work. Okay, to name that plane, we needed 3 non-collinear points. So when question 3 asks, name 3 non-collinear points, we know we can just put B, C, and D. There are 3 points that aren't all on the same line. Number 4 is asking to name 2 lines that intersect and the point where they intersect. So let's just pick the 2 lines in the plane. So one line in the plane is line BC. Okay, so we got to put the arrows on both sides because it's a line. And that's going to intersect line CD. Okay, and it's going to intersect. Oops. Okay, it's going to intersect at point C. So it's going to intersect at point C. Okay, question 5 is asking us to name a set of opposite rays. So again, opposite rays, there are 2 conditions for a pair of rays to be opposite rays. They have to share a common endpoint is the first condition. Second condition is they need to form a straight line. So we basically need to look for a line with at least 3 points on it. Okay, and the only line on here with 3 points labeled on it is line AE. Okay, so let's look for the middle point B. So we can take a ray BA. Okay, so there's ray BA. The arrow is over the A because B is our endpoint. And we're going through A to infinity. An opposite ray to ray BA is going to share the same endpoint. So it's going to have an endpoint of B. And then it's going to form a line. So it's got to go in the opposite direction. So it's got to go down. And that's going to be ray B, E. And the arrow is over the E because that's the direction the ray is going. Starts at the endpoint of B and then goes forever through E. Okay. So that's the first diagram. Second diagram. Bunch of questions for the second diagram. So it wants us to name all the planes. So we have a cube that's looks like it's sitting on a two-dimensional surface here atop, a tabletop or something. So we need to figure out how many sides, how many planes we're going to have. Planes are the two-dimensional flat surfaces. So if we take a look at a cube, this isn't exactly a cube. It's a trapezoid prism. I don't know the official name here, but it's some sort of trapezoid-looking prism. But it's the same idea as a cube. So you're going to have a front, a back, a left, a right, a top, and a bottom. Okay, so we got to name all of those. So let's start with the top. So here's the top plane. Right, here's our top plane. All this. Okay, so we need to pick 3 points that are in that plane that aren't all in the same line. So we can pick, how about T, Q, and P? So we can name this plane T, P, Q. Okay. Now we can pick, how about the front? So here's the front of our cube. So this is the front plane. Okay. 3 points that are on the plane. To name the plane, we need 3 non-collinear points that are on the plane. So how about W, P, and N? So plane W, P, N. How about the back? Okay, so here's the back. We want to pick 3 points that are on that plane that aren't all on the same line. So how about T, Q, and R? So plane T, Q, and R. Okay, let's pick one of the sides now. Okay. It's shaded. So 3 points that are on that plane might be R, Q, and P. So plane R, Q, P. And we can do the other side. How about WTS? Plane WTS. Okay. And then we have the bottom. So the bottom here is sitting on plane A. So we can name plane A in 2 different ways. We can call it plane A. Okay. Or we can use 3 points that are on the plane. So 3 non-collinear points that are on the plane. So we could use M, N, and R. But we know, so the bottom of our trapezoid cube, or prism, trapezoid prism here, is plane A. Because we know that plane A is the same as plane M, N, R. M, N, and R are 3 points that are non-collinear that are on plane A. So we know the bottom of our prism, that plane is the same as plane A, right? Because all of these planes really extend on forever. They just don't show us because there's no way to draw it forever. So even though they have them contained here, they really go on forever. So the bottom really goes on forever, and it's represented by plane A. So those are our 6 planes. There are 6 planes here. 1, 2, 3. Top, front, back, right, left, and then the bottom plane. 6 planes. Okay. 3 collinear points. The only set of 3 points that are drawn that are on the same line are going to be right here. That's going to be M, S, and X. Our points N, S, R, and W coplanar. N, S, R, and W. So no, they are not, right? S, N, and R are all on the bottom plane. They're all on plane A. W is not on that plane, so they're not all on the same plane, so we can say no. Okay, if we wanted to give a reason, couple different explanations we can give, but we can say point W is not on the same plane as M, N, and R. Okay. We could also say that Oh, that's the best option we have. That's the best explanation we can get. Okay, W is not on plane A, but M and R. Okay, and we know that for every set of three non-collinear points, there's exactly one plane. So we know there's not another plane that M, N, and R are all going to be a part of. Okay, because there's exactly one plane that contains those 3 points together. Okay. What is another way to name plane A? Well, we just said that. So another way to name plane A was plane N and R. Okay. Where do QR and SR cross? Line QR. So here's line QR. And we want line SR. So they are 2 lines. Where do we know 2 lines are going to intersect? They're going to intersect at a point. In this case, that point is point R. Okay. But let's scroll down. We're still using the same diagram. So I'm going to have to go up and down a little bit here. And name 2 lines or segments in their intersection other than question 10. So if we scroll up to our diagram, we can pick any 2 lines here. So how about TQ and TW, and they're going to intersect at point T. So what did we say? TQ intersects TW, line TQ intersects line TW at point T. Those 2 lines always meet at exactly 1 point. If 2 lines intersect, they're going to intersect at exactly 1 point. All right. Then here we have always, sometimes, or never true. Okay. TQ, line TQ and line QT are the same line. We don't even need to look at the diagram. That's true. Are these part of the diagram, or are these all separate? These are all separate. We don't need to look at the diagram. So we know line TQ and line QT are the same. So if we have 2 points, T and Q, there is exactly 1 line. So this is always. There is exactly 1 line that between 2 points. So for any 2 points, there's exactly 1 line that will go between those 2 points. There's no other line we can draw connecting T to Q. So that means these 2 lines have to be the same. Ray JK and ray JL are the same ray. So we have, let's draw JK. So here's ray JK. Is it the same as ray JL? Well, we don't know where L is. Okay, if L is right here, then yes. Okay, if L is there, then yes. If L is over here, then no, they are not the same ray. Okay, this ray here is clearly different than this ray if you put L over here. But again, if we have L here, JL is the same as JK. Okay, so this is sometimes. Right, our other example was J. I'll put L part. Well, no, I don't want to confuse. Intersecting lines are coplanar. Okay. So intersecting lines are coplanar. Let's think about that. I think that's always true. Let's think if we can think of a scenario where it's not. Right, and the reason why 2 intersecting lines are coplanar is that lines are one-dimensional, planes are two-dimensional. So if we have a line, then we have another line, we now have two dimensions. So we can draw a plane that covers those two dimensions. So I think this one has to all be always. I don't think there's a scenario where it's not. 4 points are coplanar. They can be. So we can draw a plane here. So it's plane pi. We can put points A, B, C, and D. There's coplanar. Or we can do a plane here, plane pi prime, where we have A, B, C, and D. Okay, so sometimes. A plane containing 2 points of a line contains the entire line. So a plane that contains 2 points of a line contains the entire line. I probably should have read these beforehand. That looks like an always as well. Yeah, let's think about the best way to explain that one. Okay, a plane containing 2 points. So if we have 2 points, right, we need 2 points to define a line. So there's exactly one line. So if we have a plane, A and B are in the plane. Okay, if there's one line, there's exactly one line. There's no way we can make that go out of the plane. And again, it has to do with the dimensions, how many dimensions there are. So 2 points are going to form a line. That line is going to be one-dimensional. So if those 2 points are in the plane, then that's going to be one dimension of the plane. So that's going to be an always. 2 distinct lines intersect in more than 1 point. Okay, that's going to be a never. Okay, the lines either intersect or they don't. If they don't intersect, they're parallel lines. If they do intersect, they're going to intersect at exactly 1 point. So that one is never. Depending on your definition of parallel, you could have, there's skew lines, which, again, depending on how you define parallel, they may or may not be parallel. But for our purposes, parallel. All right, now to the other side where we got to do the sketches. Okay, so 18, we want to complete the figure to the right and show the following relationship. So we have 3 lines, L, M, and N, and they're coplanar, and they lie in plane Q. And so here's our plane Q. So we have 3 lines in the plane, L, M, and N. Okay. Lines L and M are going to intersect at point P. Line N intersects M and N at R, but does not intersect line L. So since they're in the same plane, and we know that N is not going to intersect L, we know N and L are going to be parallel. They're not going to intersect. So N and L. We know that L and M intersect at point P. So we can put M here, and they're going to intersect at point P. Line N intersects line M at, wait. Let's go back. L and M intersect at point P. Okay, and this is going to be, okay, and then N and M intersect at R, but N does not intersect L, so they're parallel there. So there we go. That one's good. Okay, 19, complete, same thing. Okay. So we have a plane R. Okay, this one doesn't give us our plane name in the corner, so we got to put our R in here. Plane R. Contains lines A, B, and D, E, which intersect at point P. So let's put those in. A, B. And D, E. Probably should have read the whole thing before I proceeded, but that's okay. We can erase if we need to. And they're going to intersect at point P. Add point C on the plane so that it is not collinear with AB or DE. So point C. Right, not collinear, meaning it's not on the same line as either one of those. So it's not on line AB, it's not on line DE, but it's in the plane. Okay. Draw and label a plane Q that satisfies the relationship. So we have plane Q. We have line AB in the plane. We have line ST intersecting AB at P. We have a point X that is collinear with points A and P, a point Y that is not collinear with T and P, points T and P, and line L contains points X and Y. So let's start here. Okay, so we have a line AB. So let's put in our line AB. We have a line ST that intersects this line at point P. So a line ST that's going to intersect at line AB at point P. Point X is collinear with points A and P. So X needs to be on this line. It's collinear with A and P, meaning it's on the same line as A and P. And there's only one line. There's exactly one line that's going to go through points A and P. So we can put X anywhere on that line. Point Y is not collinear. So this is X. So point Y is not collinear with points T and P. So not collinear. So not on the line. So again, we can put Y on whatever line we want. Let's put it right here. Okay. And line L contains points X and Y. So then we can add a third line in here. And we can call it line L. Okay. So point S is right. This is point S. This is point X. Here's point Y. Okay. And that's it for that one.